All right, you guys, we're back. And now the last thing we're going to investigate is what is the appropriate measure of center and spread for a data set. Okay. And we're going to do this through the use of this example about the Los Angeles Lakers basketball team. Okay. So let's read it together. The table below gives the approximate salaries in millions of dollars of the 12 members of the Los Angeles Lakers basketball team for the 2002-2003 season. Okay. So you can see Shaquille O'Neal and Kobe Bryant made quite a bit more than some of the other players. What I want you to do right now is I want you to take your calculator out. I want to put the list of data into L1, and I want you to calculate the 5-number summary, the mean and standard deviation, and the range of the data. So pause the video now, do that, and come back, and let's look at what we got. Okay, when you did that, what you should have gotten was 5.1 for the mean, 6.6796 for the standard deviation, 0.4 for the min, 1 for quartile 1, 3.35 for quartile 3, for the median, 4.95 for quartile 3, and 23.6 for the max. The IQR is 3.95. The range is 18.5. Okay, so that's the first thing we have. We need our data, and now we want to investigate what's more appropriate to report when talking about the measure of center. Okay, so part B says compare the mean and the median. So I want you to look at the mean. So I'm going to circle it, or maybe I'll highlight it. Okay, so the mean is right here, 5.1, and the median is 3.35. And what do you notice? Okay, you should notice that the mean is not less than the median, but the mean is greater than the median. Okay, the mean is greater than the median. Okay, now what we want to do is we want to look at the data in our calculator in a histogram. What is the shape? So I want to show you right now how to make some plots in your calculator. So get your calculator out. The data should already be in there. Okay, I'll pause it one more time, give you a second to get that date calculator or the data in if you haven't. And I want to show you how to plot this data. Okay, so you have your list 1 of your data. And now what we want to do is we want to look at some different plots right now. And it says, look at the data in your calculator in a histogram. What is the shape? We could look at anything though. What I actually really want to show you is a box plot. So I can start to teach you how to describe a box plot because we missed that on the last video. So if you hit second and you go to y equals, you can see right above there, it says stat plot. We're going to look at a plot of some statistics. Okay, so second y equals, sorry, I did it again. And you should see this screen right here. We're going to hit enter on 1. I want you to hit enter on because we want the plot 1 to be on. And now what you can see here is we have a scatter plot, a line plot, a histogram, a box plot, a modified box plot actually, and then a regular box plot, and we call this a probability plot. So let's go ahead and look at the histogram. Okay, so I'm going to enter on the histogram, and it says X list there. That means what data is it? Where is your data coming from? Is it coming from list 1, list 2, list 3? And ours is coming from list 1. So everything's all set to go. And now what I want to do, the nice thing that's a little bit different than Calc or Algebra 2, you don't have to mess with your window and figure out what your X max, X min, Y max, Y min should be. You can just go ahead and hit zoom and go all the way where 9 is. So zoom 9, hit enter. Oops, and so if you're in a different math class, I had another function in there I should have gotten rid of. So I'm almost glad that happened. So I want to clear out that function, okay? I'm going to hit zoom 9 again. And you can see, wow, this is a very skewed right graph, okay? In fact, these are probably some potential outliers, okay? And we could do the outlier rule to check, although I'm going to just let you know that those are outliers. Kobe Bryant and Shaquille O'Neal are outliers. And I'm going to show you that with the box plot here in a second. But you can see that it is skewed right, okay? How did I know it was skewed right? Forgive me there. I know it's skewed right because the thin part is all on the right-hand side. Now, I'm not going to have you practice the outlier rule right now unless you want to. I want to show you just a quick check for the outlier rule Now you do need to show your work. You need to know how to prove that something's an outlier. But if you wanted to just quick check and see if something was, if you go to second y equals, go to plot 1, hit enter, and go all the way over to the box plot with outliers and hit enter. Again, X list, that means our data is coming from L1. And now we're going to hit zoom 9. And you can see, sure enough, look at that. If I hit trace now, I can look at, here's my 5-number summary. And then what it can also tell us is, hey, that's an outlier, 12.4 and 23.6. So Shaquille O'Neal and Kobe Bryant are indeed outliers. All right. Okay, so now that we know that 12.4 and 23.6 are outliers, what we want to do next, you guys, is we want to go ahead and, I didn't do this. You can keep it in L1 actually. If there are outliers, we want to retype the data in L2, omitting the outliers. So what I did is I just went, because it's fine, I'm not going to show you a side-by-side box plot. I just went to stat, I hit enter, and then now keep in mind, mine was entered a little bit weirdly. So you want to find Kobe Bryant and Shaquille O'Neal. You want to find their data, and that's that 23.6 and the 12.4. Most of yours should be at the top. Mine's in the middle just because I entered it in weird. I'm going to hit delete 23.6 and I'm going to delete 12.4. So now what the question is saying, it says, are there outliers? We said yes. Retype the data, omitting the outliers. Okay, we did that. Now it says find the distribution of the data. What happened to the center and spread? So what we want to do right now is we want to recalculate the mean, the standard deviation, and the 5-number summary. So I want you to do that now. So what we did is I didn't re-enter it into L2. That's okay, because I'm not going to have you do the last parallel box plots. Okay. So in L1, we took out Kobe Bryant's salary as well as Shaquille O'Neal's. Okay. And we re-ran the one variable stat. So that's what you were supposed to do. Okay. Pause it now if you didn't, but I do have the data over here as well. So you can see here, I have my mean. I'll highlight that mean. I have my standard deviation. Okay. I have my 5-number summary, and my median now is 2.25. My IQR is 2.9, and my range is 4.9. What I also want to do is I want to highlight here this, because that's a measure of spread. That's a measure of spread, right? Here's another measure of spread and some more measures of spreads, right? Okay, so now what we want to do is we want to investigate this. It says, compare the mean and the median of the new distribution. Okay, well, the mean and the median of the new distribution are not that far off. We're not going to say they're equal, but they're pretty dang close, 2.52 and 2.25, okay? What just happened? Now, I'm going to ignore the rest of this stuff here. I'm not going to worry about this, but what we want to do is we want to have an important conversation. If we put Kobe Bryant and we put Shaquille O'Neal's salary back in, and we look at our data here, you guys, if I asked you to report the most appropriate measure of center, would you pick the mean or the median? You may be thinking, I don't know, but let's just see what happened to the mean when Kobe Bryant and Shaquille O'Neal were taken out. It dropped, it went way down, okay? What that means for us is the mean is very affected by outliers. In fact, what we say is we say the mean chases the outliers, okay? That makes sense because we're adding everything up when we're finding that mean. So that outlier is bringing that sum up in regards to that basketball problem there, okay? So what would be the most appropriate measure of center? Not the mean, because it's so affected by Kobe Bryant and Shaquille O'Neal. But we want to report the median. The median is not as affected by extreme observations. Okay, you can also notice here too, the standard deviation, 6.6796. That's measuring the spread. On average, how far are the observations from the mean? That spread is also much higher when Kobe Bryant and Shaquille O'Neal are there. But when they're taken out, it goes down. It's not, the data is not as spread out, which makes sense. Now the IQR is not as affected by extreme observations, but the range is. Okay, so this is where the term resistance comes in. The lessons we should learn here. This is what we want to write down. If we haven't written anything down yet, this is what we want to write down. The mean, standard deviation, range are not resistant to outliers. They're greatly affected by them, as we just saw here with this example. The median and the IQR are resistant to outliers or extreme observations. When a distribution is skewed, use the median and the IQR to describe the distribution. When a distribution is symmetric, use the mean and standard deviation to describe the distribution. But finally, there's a catch. Unless it's a box plot, then you always use the median and the IQR to describe the distribution. With that being said, I want to do one comparison because that's just so important, okay? And then we'll be done for the day. What I want to do is I want to look at these two box plots, okay? And I want to compare learning from the previous video. So we have distribution X and we have distribution Y. And remember, anytime you're asked to discuss the distribution or describe the distribution or whatever it may be, you need to remember SOX, okay? So you're talking about the shape and the spread. So I do want to talk about the shape of box plots now. Like, how do you decide if it's symmetric or is it skewed? And in my opinion, the best way to think about this is you look at the median, okay? And then you go all the way out to the tails, okay? And you fold it in half in your mind. Would it approximately match up? If it would approximately match up, then the distribution is symmetric. Okay, I'm going to get rid of those. So before I get rid of it, let's talk about X. Would you say this is symmetric or skewed? I think that is approximately symmetric. It's symmetric enough for me, at least. Now, look right here where we have the median here. Now I'm going to put a line to the tail. And then I'm going to put another line. Is this going to match up? No, when I fold it over this line, are these tails going to match up? And they're not. We're going to have a longer tail over here on the left side. So we call that skewed left then. Okay, so let's describe it now. Just like I was saying, I want you to get in the habit of always just using the median and the IQR, okay, when we have box plots, no matter what. Okay, so I'm going to type it out for us. The distribution of X is symmetric, whereas the distribution of Y is skewed left. Okay, let's talk about the outliers for SOX. There are not any outliers for either distribution. Okay, the center for the Y distribution is greater than the center for the X distribution. We're looking at the medians. We don't have to say what they are. We just have to say that they're greater. So the center for the Y distribution is greater than the center for the X. Now let's talk about the spread. The spread, so what am I looking at? I'm looking at the IQR. So that's this space right here. From quartile 1 to quartile 3, it's that difference. Okay? The difference, the spread of the Y distribution is greater than the spread of the X distribution. All right, perfect, you guys. You did it. We are done now for the day. I know it's a lot, you guys. It's a lot getting used to this block schedule, but you're doing awesome. So keep it up.